Welcome to Amateur Radio's Reflector Magazine by the East Coast Reflector. Volume 22 of the Reflector Magazine, November 2025. Articles featured in this volume: Dick's Corner, The Antenna Farm, Earth-Moon-Earth Operations, Leaf Attenuation, Grid Dip Oscillator, Celebrity Callsign, 5VBY Roy Dolby. You'll also find information on nets, user-submitted pictures, comics, Ask an Elmer Zoom meetings, how to connect to ECR, ECR Town Hall, puzzles, ECR events, silent keys, and more. Table of Contents. Table of Contents.
Connecting to ECR is simple, and there is no membership or club to join. Everyone is welcome. There are no fees or permissions. Just connect. If you have audio or connection issues, we're here to help. Simply free. The way that air was meant to be. Dick's Corner by WB2JPQ. In this article, the East Coast Reflector is buzzing with activity, from friendly weekly nets to new digital links and upcoming holiday fun. Here's a quick roundup of what's new and how you can get involved. 20 meter net. Every Thursday at 10 a.m. on 14.317 MHz with Roger KO for QMM and Randy W2 RBC. New DMR bridge added. Joe KO for FRR has launched a new bridge on talk group 3215714, expanding ECR's reach for digital users. Volunteers wanted. Front and back-end developers are invited to join Joe for a few hours a week in improving the ECR website and future projects. Tuesday TechNet Refresh. We're looking for fresh ideas, topics, and guest operators. Your input helps shape the net's next chapter. Santa on the Air. Email your wish lists to ecrhohoho@gmail.com for this year's Christmas event, a fun, heartwarming ECR tradition. Repeater expansion. Know a quiet local repeater that might link with the ECR? Send the trustees' contact info to help grow our network. Roger KO for QMM. A few years back, Roger KO for QMM came to me with a simple but exciting idea. Why don't we start a 20-meter net? As anyone who's ever launched something new in amateur radio knows, it takes both enthusiasm and persistence to keep it going. Roger, along with Randy W2 RBC, turned it into one of the most enjoyable nets on the East Coast Reflector. Week after week, every Thursday at 10 a.m. on 14.317 MHz, they've welcomed hams, creating a great spot to chat, share stories, and check in with friends. It's not just a net, it's become a weekly meeting place where new voices are always greeted warmly. Many thanks to Roger and Randy for their ongoing dedication and hard work in keeping the ECR 20-meter net strong and successful. If you haven't checked in yet, grab your coffee and join the fun this Thursday morning. Did you know the ECR has HF nets too? Join the 20-meter net on Thursday mornings at 10 a.m. on 14.317, and the 40-meter net on Saturdays at 9 a.m. on 7.245. The TechNet. Now, shifting gears a bit, we're taking a fresh look at our Tuesday night TechNet. This net has always been about sharing knowledge, exploring new ideas, and helping one another solve problems. But we'd love to hear from you. What topics or formats would make the net even more engaging? Do you have a suggestion for a regular segment, a guest operator, or maybe a theme night? Your ideas help us shape these nets into something everyone enjoys. Just drop me an email wb2jpq@aol.com. Looking for volunteers. Behind the scenes, there's a lot happening with our ECR website too. Joe KO4FRR is looking for both front-end and back-end developers to join the effort for a few hours a week as we plan some exciting upgrades. If you've got a knack for coding, design, or just an interest in helping improve the ECR growth, this is your chance to make a lasting contribution. It's a great way to combine your tech skills with your love of ham radio, and Joe would certainly appreciate a few extra hands on deck.
Volunteers wanted. Offering to help is always appreciated. Though it may not always lead to an immediate role, sometimes it just takes time to find the right fit. Our projects are collaborative, and even small changes can impact many parts of the system. That's why we work together as a team to make sure everything runs smoothly. All positions are a few hours a week at most. Facebook. Facebook image collecting. Download Facebook pictures, name them with date and call sign, and copy-post link into the details. Magazine. Plain text. Create the monthly plain text version of the magazine. Mastodon. Radio. Mastodon administrator. Post announcements. Net's Open Mic Net. Guest net controllers. Store manager. Process orders for the ECR shop. Web. Front-end and back-end developers. Zoom. Greeter. Welcome and greet people as they come into Zoom. YouTube. Podcasting. If you have a skill that you'd like to offer that isn't listed, we'd love to hear from you. Text or call 716-427-4142.
Santa. And believe it or not, the holiday season is right around the corner. Once again, we've extended a special invitation to Santa Claus himself to drop by the East Coast Reflector and read our users' Christmas wish lists on the air. It's always a fun and heartwarming event that brings a smile to everyone listening. If you'd like Santa to deliver a shout-out or send a special message to someone on the ECR this Christmas, please email your wish list to ecrhohoho@gmail.com. Let's make it another season filled with laughter, friendship, and good radio cheer. The ECR has a new bridge. Thanks to Joe, KO4FRR, we now have a new DMR bridge under the Callsign W2ECR. Check out TG3215714. The first time you connect, and only the first time, you will need to key up once to get started.
Santa is coming back to the East Coast Reflector. Check in and talk to Santa on the air. If you're too shy or not available, you can send him an email and he'll read your letter on the air and respond. Adults are welcome to send messages or thanks to loved ones or just say hello. And of course, third party is also welcome.
Finally, as we continue to grow, we're always on the lookout for quiet local repeaters that might be a good fit to link with the East Coast Reflector. If you know of one in your area that isn't currently connected and has a trustee open to collaboration, please get in touch. All I need is an email address for the trustee, and we'll take it from there. Expanding our reach helps bring more operators into the fold and keeps the airwaves alive with great conversation. Ask an Elmer Zoom recap. The recent Ask an Elmer Zoom on the East Coast Reflector drew a full crowd and plenty of good discussion. The group covered everything from antenna theory to mobile operating tips, with a mix of familiar voices and newcomers joining in. Charles KC6 UFM opened with a clear explanation of the UNUN versus BALAN question. The UNUN links unbalanced antennas to unbalanced feed lines, while the BALAN connects balanced antennas, such as dipoles. Lightning protection and grounding followed. The consensus: place surge protectors at the antenna feed point, keep ground runs short.
The Ask an Elmer Be an Elmer Zoom meeting is a great place for new and seasoned hams. Join us in Zoom at 8 p.m. on the first and third Thursday of each month. Come in and ask for help and get respectful answers from a family-friendly environment. If you don't have any questions, you're welcome to come and watch.
And straight, and use a suppressor rated close to the operating power. Randy, W2RBC, reminded everyone that more than a volt between earth and building grounds signals a need for bonding. Bill N2BH sparked interest with a discussion on DV switch, which can turn a smartphone into an all-star node via bridge 598529. Press noted that mapping a volume button for PTT works well, and several operators reported clean audio when run through car systems. Daryl closed with notes on his FlowerPot antennas, simple to build and impressively quiet across multiple bands. The Ask an Elmer sessions continue to be a welcoming space for all hams, a mix of learning, sharing, and good conversation each time the reflector keys up. Join us every first and third Thursday, 8 p.m. Eastern Standard Time in Zoom. We've also got a couple of great presentations lined up this November in the ECR Zoom room at bit.ly/ECR Daily. On Monday, November 10th at 8 p.m. Eastern, join Daryl VK3AWA for a hands-on session on building a FlowerPot antenna. This clever design is perfect for those in HOAs or apartment balconies, simple, affordable, and surprisingly effective. Daryl will walk us through how it works, how to build it, and how to get the most from limited space.
The ECR presents a FlowerPot antenna build, Zoom presentation, by Daryl VK3AWA. Join Daryl as he walks through building a FlowerPot antenna. Great for small spaces. Monday night on November 10th at 8 p.m. Eastern. In the ECR Zoom room at bit.ly/ECR daily. Or go to eastcoastreflector.com and click on the Zoom link.
Then on Monday, November 17th at 8 p.m. Eastern, Dave N2EZY from the Antique Wireless Association will be giving a fascinating presentation on vintage radio history and restoration. If you enjoy classic gear, glowing tubes, and learning how our hobby evolved through the decades, you won't want to miss it. Dave's presentations are always engaging and full of great stories from radio's golden age. Also in the ECR Zoom room at bit.ly/ECR daily. Thanks to everyone who continues to support the ECR in so many ways by checking into nets, volunteering, helping others, or just being part of the community. It's your enthusiasm that keeps this network going strong. See you on the air. Dick, WB2JPQ.
The ECR presents the Antique Wireless Association Zoom presentation by David N2EZY. Join David as he talks about the Antique Wireless Association, a museum committed to collecting and preserving early wireless radio equipment. Monday night on November 17th at 8 p.m. Eastern, in the ECR Zoom room at bit.ly/ECR daily. Or go to eastcoastreflector.com and click on the Zoom link. Next.
We've done it again. The ECR has just gotten a little bit bigger. There's a new DMR bridge to the ECR. Hook up at talk group 3215714. The first time you connect, you will need to key up once to activate your connection.
QSL cards courtesy of hamgallery.com.
The ECR TechNet has been around for over 12 years. Join us Tuesday nights at 8 p.m. Eastern. We welcome you to ask questions, help answer questions, or just listen and take in the information. Experts are available to answer your questions. If they don't know the answer, we open it up to the net users to help get your answers. After the questions are over, general check-ins are taken. Tuesday nights at 8 p.m., and you can view the log at bit.ly/ECR logs.
Viewer-submitted pictures.
Try a taste of the general exam. Try a handful of general exam questions for practice, review, or just for fun. It only takes a few minutes. No login required, and in the settings you can set the questions to be read aloud.
The Antenna Farm, Part 37, Earth-Moon-Earth Operations. This edition of the Antenna Farm explores Earth-Moon-Earth, or moon-bound communications, one of the most challenging and rewarding areas in amateur radio. While not a beginner's project, EME demonstrates the limits of RF path design, antenna gain, and signal sensitivity. Concept: EME uses a moon as a passive reflector to send signals over vast distances. Path loss: enormous signal loss, 374 dB total, requires high-gain antennas and precision systems. Antenna systems: large Yagi arrays or parabolic dishes with circular polarization and dual-axis tracking are essential. Feed line: hardline coax or remote operation minimizes transmission losses. Modes: digital modes dominate. Voice possible but challenging. Experience: EME demands skill, planning, and investment, but offers exceptional technical rewards. Next topic: impedance matching transformers. Hello, ECR family, and welcome to the Antenna Farm. This is your friendly antenna farmer, Charles, KC6UFM. As always with the Antenna Farm topics, I welcome any and all feedback from you, the reader. I am almost always monitoring the East Coast Reflector, and my email is on my QRZ page. I am also on the ECR for almost every Tuesday night TechNet, so this would be a great place to ask questions. 2. Feel free to reach out to me with any comments or questions. But there's a new, and in my opinion, great place to ask questions about the Antenna Farm or antenna systems in general. Join me, along with other Elmers, in the East Coast Reflector Zoom room on the first and third Thursdays of each month at 8 p.m. for the Ask an Elmer Be an Elmer event. This is a chance for all hams, especially those new to the hobby, to ask questions that may be too involved to get detailed answers from the TechNet. I look forward to you joining us and asking your questions. Today at the Antenna Farm, we're wrapping up our series of articles looking at antennas for use in space communications. This time, we're looking at the real big guns of the amateur space communication systems. EME or Earth-Moon-Earth. Before we dig into EME, I want to tell you that this Antenna Farm article is a little bit different in that we're not going to get into building an EME antenna. That is a huge undertaking that not many can complete because of the expense, the time needed to do it, and the need for a lot of real estate for the antenna array. The goal here is to show you one area of ham radio where that excess loss of 0.1 dB really does matter. General information, Earth-Moon-Earth, usually just called EME, is sometimes called moon bounce because the idea is to use the moon as a passive reflector of radio signals. As hams, we've all experienced a situation where a signal from another station, especially mobile stations, fades in and out as the transmitter moves. This fading is due in part to the signal reflecting off of or refracting around things in the path between you and the transmitter. Buildings, hills, and mountains, trees, and other structures can cause this effect. In the vast majority of cases, this alteration of the incoming signal is accidental and usually considered to be an irritation. However, in some cases, this reflection and refraction of the signal can be both deliberate and beneficial. Sometimes, you might want to bounce your signal off of a mountain to reach another station that is located such that you can't reach them otherwise. Bouncing a signal off of the moon is the extreme of this case. With EME, the goal is to use the moon as a passive reflector of radio signals, so they can be received at very great distances from your location. There are, of course, some huge hurdles to overcome to make this deliberate reflection happen. EME path losses and overall circuit calculations. The distance from the Earth to the Moon is about 238,855 miles on average. Sometimes the Moon will be a little closer, and other times it will be a little farther away, because the Moon's orbit around the Earth is not a perfect circle. That's a long way. To put it into perspective for you, the Moon is 97 times the distance from Los Angeles to New York City. This distance is doubled, however, because it's 238,855 miles to the Moon and another 238,855 miles back to the Earth, a total of 477,710 miles. Needless to say, this distance introduces a staggering amount of path loss. Continued on page 67. There's a link in the description below if you want to jump there now. The Reflector Magazine is available on YouTube. Watch along on the pages and listen to the voiceover as it reads to you. It's great for blind, visually impaired, people who prefer to listen to the audio, or people who need something to listen to while they mow the lawn. If you know of someone who would benefit, pass it along.
The YouthNet is run from the East Coast Reflector Zoom room with the support of the ECR team. All kids and their parents are welcome to come in the Zoom room at 7 p.m. Eastern, an hour before the net, to hang out, get to know each other and see how the net runs as you follow along on the log sheet. Third-party check-ins are encouraged. Adults are welcome to check in. Kids are welcome to check in with each net controller. Join our YouthNet controllers every Friday night. Support the future of ham radio. Friday nights at 8 p.m. Eastern Time. Viewer-submitted pictures.
Callsign word search. Play on your device. Find the call signs of people whose birthday is this month.
Leaf Attenuation by Randy W. 2RBC. In this article, leaves and moisture in vegetation can absorb, scatter, and weaken radio signals, especially at higher frequencies. Understanding these effects helps amateurs plan more reliable communications. Absorption. Water in leaves absorbs higher frequency signals, VHF and above. Scattering. Branches and leaves cause signal reflections and multipath distortion. Seasonal variation. Summer foliage increases loss. Winter bare trees reduce it. Frequency dependence. HF largely unaffected. VHF/UHF lose several dB per 100 M. Microwave nearly blocked. Moisture impact. Wet leaves absorb more. Dry or snowy leaves cause less loss. Bottom line, HF bands pass through foliage easily, but higher frequencies can fade fast in wet, leafy conditions. Leaf absorption. 1. Absorption. Leaves contain water and other organic material that absorb radio waves. The higher the water content in spring, summer, or after rainfall, the greater the absorption. At VHF and higher frequencies, 30 MHz and up, absorption can be significant. HF bands, 3 to 30 MHz, are much less affected since longer wavelengths pass through foliage more easily. 2. Scattering and diffraction. Leaves and branches cause scattering, which can reduce signal strength and create multipath interference. Dense canopies can cause the signal to take multiple indirect paths, degrading clarity and strength. At UHF and microwave frequencies, this effect is especially pronounced. 3. Seasonal variation. Summer, full foliage, strongest attenuation due to water-rich leaves. Winter, bare branches, much lower attenuation, especially in deciduous forests. 4. Frequency dependence. HF, shortwave, like your 20M amateur radio band at 14 MHz. Only minor effects, since the wavelength is 20 meters, much larger than leaves. Forests might cause some attenuation, but not dramatic. VHF/UHF, 50 MHz and above, like 2M and 70 centimeters bands. Noticeable loss in wooded areas. Foliage can add several dB of attenuation per 100 meters of dense forest. Microwave, greater than 1 GHz, like Wi-Fi, satellite, radar. Very sensitive to foliage. Even a tree between antennas can severely reduce or block the signal. 5. Moisture and weather effects. Wet leaves increase absorption significantly. Snow on branches tends to scatter more than absorb. Dry leaves cause less loss than green, water-filled leaves. In summary, on your 20M amateur band, leaves don't cause much trouble. The signal mostly goes through or around them. On higher frequencies, VHF/UHF microwaves, leaves can cause major signal weakening, especially in summer or wet conditions. Chart of leaf attenuation by frequency. Leaf attenuation by frequency. HF 3 to 30 MHz. Wavelengths 10 to 100 M. Effect: very little attenuation. Leaves are tiny compared to wavelength, so most energy diffracts around or through. 20M band, 14 MHz, essentially unaffected. A dense forest might add a fraction of a dB. VHF 30 to 300 MHz. Wavelengths 1 to 10 M. Effect: noticeable attenuation, especially above 100 MHz. Example: 50 MHz, 6 meters, 1 to 2 dB per 100 M of dense forest. 144 MHz, 2 meters, 3 to 6 dB per 100 M of dense forest. Notes: summer foliage, especially when wet, can make handheld radios in woods seem much weaker. UHF, harom saz MHz to harom GHz. Wavelengths, 10 centimeters to 1 M. Effect: strong attenuation. Leaves cause scattering and absorption. Example: 433 MHz, 6 to 10 dB per 100 M of dense foliage. 900 MHz, 10 to 15 dB per 100 M, can double if wet. Notes: tree cover can seriously limit handheld and repeater coverage. Microwave, 3 to 30 GHz. Wavelengths, 1 to 10 centimeters. Effect: severe attenuation. Just a single tree or wet canopy can block signals almost completely. Examples: 2.4 GHz Wi-Fi, 10 to 20 dB per tree, especially when wet. 5.8 GHz Wi-Fi microwave links 20 to 30 dB per tree, often unusable through foliage. Notes: for point-to-point microwave or satellite, even one leafy branch can kill the liquor. Millimeter wave, greater than 30 GHz. Example: 5G mm wave, 60 GHz WiGig. Wavelengths, millimeters. Effect: Extreme attenuation. Even a single leaf can cause significant loss. Example, a row of trees equals essentially total blockage. Bottom line for you. On 20 meters, 14 megahertz, leaves are not an issue. But if you use handhelds or repeaters on 2M or 70 centimeters, or any microwave gear, you'll definitely feel the foliage effect, especially in summer or after rain. Previous articles by Randy W. 2RBC available in the archives.
Connections printable. There are many ways to connect to ECR. For a printable list, go to bit.ly/ECRconnect. There, you will find the information on the many different ways to connect.
We've always got something going on, and you're invited. Go to eastcoastreflector.com and click on Events Calendar. See what's going on for the month, or subscribe to the Google Calendar and get updates. Google will automatically update your time zone.
Open Mic Net. The ECR has a one-of-a-kind net. It's an open mic net for net controllers. Every Wednesday night at 8 p.m. we have multiple guest net controllers. You can be on too. No experience necessary. You don't even need to log, just read from the log sheet. If you're interested in being a net controller on our open mic net, sign up at bit.ly/ECR open mic.
Viewer submitted pictures.
Comics. You've saved all of those parts, but never seem to have the right one.
Grid Dip Oscillator by Harry SM0VPO. In this article, Harry Lythall, SM0VPO rebuilds his 35-year-old Grid Dip Oscillator into the updated Grid Dip Oscillator 2, designed for modern RF demonstrations and home experiments. The new version is more compact, visually appealing, and energy efficient while keeping the simplicity and versatility that made the original a favorite among radio hobbyists. Key points: modernized rebuild of the original GD01 for teaching and RF testing. Features: large meter, LED power indicator, dual 12V batteries, compact plastic case. Low power draw, 3.5 mA, and wide frequency range up to 200 MHz. Uses interchangeable coils and a FET-based oscillator circuit. Built affordably, US $10, and easily, even without workshop tools. Ideal for antenna tuning, signal generation, and general RF experiments. Introduction. About every 2 months I present 3-hour courses in front of up to 60 people at a time about RF, what it is, how it is handled, and RF safety in the laboratory. I use a lot of practical demonstrations because it is easier to teach when people see stuff done in practice. One demonstration is to show that any bit of wire can be an antenna, and I test the length of LAN cable using my Grid Dip Oscillator, GDO. My main problem is that my GDO1 project, published on my homepages, was built about 35 years ago. The meter is small, and to be honest, it is functional but looks really, really old. The coils are starting to become deformed, the formers are broken, and when I project the instrument, using my DV camera, on a 6-meter wide screen, it really looks crappy and amateurish. So, I decided that it is about time to build another GDO MKI, but I added a few features. The new features I wanted are: large, oversized meter, LED power indicator, twin battery operation, smaller construction, aesthetically pleasing, no metalwork or sawing. The larger meter is required so I can project it on the 6-meter wide screen for all to see the dip. I want a power indicator because it looks more pretty with a glowing LED lamp. People like to see an LED looks technical. Another point is that this 65-year-old brain keeps forgetting to switch the damn thing off after courses. I am sure that my brain has a mind of its own. batteries normally lasted more than 5 years in the old GDO1, but I have changed the battery 3 times during 2016 after leaving it switched on. I have now decided that I will use two 12V photographic batteries, so if one fails, then I can always use the other. It also needs to be mounted in a nice box, and with more robust and posh-looking coils. The GDO circuit. The new GDO2 circuit is almost identical to the old GDO1 circuit, but I have used slightly different component values in the measuring circuit to drive a slightly less sensitive meter. The LED is added in series with the metering resistance, so it does not draw any extra current for the meter. In fact, the LED has a 1.8V drop, which reduces the current the complete project draws. The complete project only draws 3.5 milliamperes, but it still gives a really strong deflection on the 100 mA meter. Projected battery life is about 100 hours per battery. I am sure it will be quite usable if you only had a 500 mA meter. Circuit of the old GDO1. Circuit of the new project GDO2. The old GDO1 used a 4-gang variable capacitor from a $5 VHF/AM radio, but this is not needed here. This uses the tuning capacitor from a $2 AM-only radio, but I bought the capacitor new from China. This project is only needed up to 200 MHz, and the 200 picofarads plus 200 picofarads, effective 12 picofarads to 100 picofarads, is good enough for up to 200 MHz. I also used a single pole on-off-on switch for the power, so that I could select either of the two 12V batteries. The oscillator circuit is based on the BC256B N-channel RF field effect transistor (FET) amplifier. It is run at about 1 mA, but this does vary a bit with frequency and the strength of oscillation. The oscillator acts as a 9000 ohms resistor, in series with a 1000 ohms resistor. This gives a voltage divider. A second voltage divider consists of a 1000 ohms potentiometer and a 3900 ohms resistor, in series with an LED. The meter movement is connected between the two voltage dividers to form a Wheatstone. The article continues on page 84. There's a link in the description below if you'd like to skip ahead.
The ECR helpline. If you're having a difficult time connecting to the ECR or need to make us aware of a problem, call or text our helpline at 746-427-4142. We'll help you the best we can. This is not for bad audio or rude hams. This is for things that need current attention, like someone sleeping on the mic about to time out the system or someone being very aggressive. We appreciate your help.
Audio check. There are great audio tools on the website at eastcoastreflector.com. There's a Listen Live player for listening anytime equipped with a visual audio meter. There's a second player with a 2.5 minute delay. This allows you to do your own audio check. To hear what your audio sounds like, load up Listen Live on the website. Pick up your radio. Give your call sign and say this is an audio test. No response necessary. Then wait a minute and listen to the playback. Still stumped? Come into our Zoom room for advice at bit.ly/ECR daily.
Join Alex W7FTM on Saturday nights at 11 p.m. Eastern for a night of trivia. Each person gets their own multiple choice question, so join us for some late night fun.
Viewer submitted pictures.
Even our jigsaw puzzles are ham-related. Choose what size puzzle you want and play on your device.
Celebrity Callsign by Joe KD2TFB. F5EBY, Ray Dolby, pioneer in audio engineering. Ray was born 18th of January, 1933, in Portland, Oregon, the son of Esther and Earl. He attended Sequoia High School in Redwood City, California, graduating in 1951. As a teenager in the decade following the Second World War, he held part-time and summer jobs at Ampex in Redwood City. While at San Jose State College and later at Stanford University, interrupted by 2 years of Army service, he worked on early prototypes of videotape recorder technologies. In 1957, Ray received his Bachelor of Science in Electrical Engineering from Stanford. He subsequently won a Marshall Scholarship for a PhD in physics. In 1961, from the University of Cambridge, England, where he was a research fellow at Pembroke College and completed his PhD titled Long Wavelength X-ray Microanalysis. Like many of these episodes, there are so many accomplishments earned by Ray that would take too long to relate in a short feature like this. You can read about them on his Wikipedia page, but I'll just touch on a few of them here. These include awards from the Audio Engineering Society, the Society of Motion Picture and Television Engineers, often said as SMPT, the Institute of Electrical and Electronics Engineers, or IEEE, a United States National Medal of Technology, honorary doctorates, Academy Awards, and an Emmy Award. If you're old enough, you most likely know Ray from making recordings on compact audio cassettes. The Ray I'm talking about is Ray Dolby, the inventor of the Dolby Noise Reduction System and founder of Dolby Laboratories. It works because the majority of tape noise is at high frequencies. So at recording time, high frequencies are dynamically boosted. Then at playback time, they are attenuated. He held the Callsign F5 VBY. Ray became a silent key on September 12, 2013, at the age of 80 due to leukemia. Previous celebrity Callsign articles by Joe KD2TFB. You asked for it, so we made it happen. The ECR is now on Discord. Join us for announcements and conversation. ecr.radio/Discord.
The Morning Brew is a light-hearted, fast-paced net. Check in and tell your barista your answer to a simple question to get your morning started. Mobile check-ins are given priority. Don't want to deal with the pileups? You can also text your call sign to 716-317-9050 or email at text@ecr.radio to get on the log. Necker.
Viewer submitted pictures. Try our ham radio crossword puzzle. All of the answers can be found in this volume of the magazine. You can solve it on your device or print it.
World Radio History. The Olden Times by X6AWE. For entertainment purposes only. Use common sense. The Radio Amateur News, April 1937. As I think back several years ago to the days of Model T Ford spark coils and crystal detectors, I wonder how many remember paying from $1 to $1.50 for a crystal that you couldn't hear much on. Of winding coils 4 inches in diameter with a dozen taps and a slider. Of several hours of hard work finally getting the thing hooked up to a pair of earphones that cost $15 and then setting tints for several more hours to hear a few dots and dashes from some distant station about 20 miles away. Boy, what fun! I will never forget my first spark transmitter. A Ford coil, a spark gap made from 2 pieces of heavy wire and a key. DX worked 5 miles if lucky. This was before the World War and licenses to my knowledge were not required. About a year later we were informed that we would be required to have a license if the signals could be heard beyond the state boundary, so with the idea in mind of increasing power a license was procured. We bought one of these tubes, Audion 3-element tubes. 3 leads out of one end and 2 leads out of the other end. This tube had 2 filaments and cost $9. With the aid of several more hours hard work, a variable 43-plate condenser, a grid leak and condenser made by suspending 2 pieces of tin foil from 2 parallel wires with a piece of waxed paper between them, a storage battery and 45-volt B battery and the same pair of headphones, we could hear most anything. Ah! Voices! The Catalina Island phone and the broadcast stations that were on 360 meters. We next procured a %KW. Spark and soon after went high power with a California KW rotary spark transmitter. From what I heard, some of the boys were having more or less trouble with their rotary gaps made with phonograph records. Asked W6CL about this. In fact, I thought the war was on when visiting one of these stations when the segments from the phonograph record began flying all around us. We were lucky to come out alive. After this experience, I decided to build a gap that would hold up and really made up a fine one. The general run of antennas was anywhere from 3 to 6 wires, and as long as we could get them on spreaders about 6 to 12 feet long. Some of the old-timers may remember that in the old Spark days, if you heard a station calling CQ before you called him, you sent the letters and meaning, "Will my signals interfere with anyone?" If anyone heard your end and thought you would QRM him, he would come back with the letters "I am meaning, stand by, you will QRM me." The old Spark transmitters were so broad that a station would cover about 1/4 of the band. Next came the 5-watt transmitting tube, which when bought cost just about as much as a house and lot, but after much saving we finally went for a tube transmitter. At this time we had no rectifying tubes and we either had to use straight AC or build a chemical rectifier, consisting of all the pint jars or tall jelly glasses you could get from the neighbors. In these we used a solution of borax with lead and aluminum anodes. This type of rectifier was very hard on the power transformer and the voltage output was low. Texas now has more full-time repeaters in Woodlands, Montgomery, Porter, New Waverly, and Conroe thanks to Charlie WA5AIR. We're glad you're home and getting better. Our prayers are with you.
Join the ECR Virtual Town Hall. Stop by our Zoom room, hear announcements, and learn about new events, offer suggestions, or find ways to help. We didn't get this big by thinking of ourselves. We did it by thinking of you. Stop in and help us get to know you. It's the second Thursday of each month in the ECR Zoom room. That's 8 p.m. Eastern at bit.ly/ECR daily.
Did you know that we have a gift shop? You can help to support the East Coast Reflector at the gift shop. You can get your Callsign put on an ECR shirt starting at $17.68, coffee mug from $12.60, or a polo from $22.49.
Viewer-submitted pictures.
Antenna Farm, Earth, Moon, Earth operations. Continued from page 26. There is also additional loss introduced by the topography of the surface of the moon, and that varies based on where the signal bounces from. Smoother areas introduce less loss than rougher areas. Depending on the exact distance, recall that 238,855 miles is in average, the frequency in use, and the exact point on the moon where the signal reflects from. The one-way path loss for an EME circuit is on the order of negative 187 dB at 144 MHz. This means that the total path loss will be around negative 374 dB. Remember this number. As an aside, as you move higher in frequency, the path loss increases. At 70 centimeters, the one-way loss is around negative 195 dB. At 23 centimeters, the loss is around negative 206 dB. But there's good news. We can overcome some of this loss with other factors that come into play. First of all, while the moon's surface in and of itself is a rather poor reflector on the small scale, the moon is a really big reflector. It's true that the moon's surface, from our point of view, is a convex curve. It's so big and so far away that we can mathematically treat the moon a very large, relatively flat surface. This great big reflector gives us a theoretical gain of around positive 143 dB. Remember this number too. As with any RF path calculation, we can simply add up the various losses and gains to get the total loss of the circuit. So far we have uplink path loss equals negative 187 dB. Downlink path loss equals negative 187 dB. Reflection gain equals positive 143 dB. So, total fixed circuit loss equals negative 187 plus negative 187 plus 143. Total fixed circuit loss equals negative 231 dB. What we have left is a gain of the transmitting and receiving antennas. These gains are the variables, things that we as hams can control. The gain of the two antennas are simply added to the total fixed losses above to calculate the total system losses. From this, it's obvious that the antennas used for EME communications must have the highest possible gain. To get the highest possible gain from the antennas, the options are very much frequency dependent. At VHF and UHF, the optimal solution is to use long boom Yagi antennas and to stack 4 or more of these antennas into an array. At SHF and up, the parabolic dish antenna becomes very attractive. Recall that as you move higher in frequency, antennas become physically smaller, but no matter the frequency, the antenna arrays for EME are big. Just to give you an idea of how big, a good starting point for 70 centimeters, EME would be a 26-element Yagi on a 20-foot long boom. Yes, I said 20 feet of boom. This antenna will have a gain of about 16.4 dBd. But to be really effective, you need at least 4 of these monsters stacked into an array with a spacing of about 5 feet 2 inches between the individual antennas. Such an array will give you a total gain of about 22.4 dBd. The hardest thing for most hams is to design and build the feed harness so that all 4 antennas get the same power from transmitter. If you think that your spouse was upset because you put up that little 3-element tri-band beam on the roof, wait until you build this thing in the backyard. Oh yeah, there's a good news. You can and should ground mount the array. It's so big that you'll never get to stay in the air on top of a tower. But there's another matter. To be totally effective, you need circular polarization. In and of itself, this isn't hard to do. You build the 4 antennas as cross Yagis with 2 sets of elements on each boom mounted at 90 degrees to each other. Then you feed the element sets 90 degrees out of phase. In other words, in addition to the power divider feed harness above, you need a phasing system to feed the crossed elements out of phase. Usually the same black box does all of this magic. It's not hard, just a little tedious.
Please take the time to check out reflector etiquette. Being on a reflector is much different than being on HF. Reflector quality is the same as a phone, so there's rarely a need to use phonetics. There are other tips available to read. You can read them in the magazine, in our welcome letter, or at eastcoastreflector.com. On the website, you can access the magazine, submit net questions, view the logs, and even watch the monitor to see who's talking.
Now, let's see what our path loss looks like if we assume that both stations have an antenna array that gives 22.4 dB of gain. Total fixed circuit loss equals negative 231 dB. Total gain from antenna arrays equals plus 44.8 dB. 22.4 times 2. Total circuit loss equals negative 231 plus 44.8. Total circuit loss equals negative 186.2 dB. And this leaves us with just 2 more variables to consider: RF power output of the transmitter and RF sensitivity of the receiver. Note that for the sake of simplicity, we're ignoring loss in the feed line between the antennas and the radios for now. We're going to look at that closer down below. Just remember that different feed lines have different losses based on the frequency in use. And in EME work, every little bit of loss, even 0.1 dB, is your enemy. Use the best feed line you can find, and don't even blink when you see the price. If we assume that you're pushing full legal limit power, 1,500 watts in the US, into the antenna, a loss of negative 186.2 dB will leave you with about 0.168 V at the receiver. In most cases, receiver sensitivity is given as the signal needed to produce a 10 dB signal-to-noise ratio, SNR. The vast majority of high-end UHF receivers need a signal of around 1 V to get this level of performance, far more than what will be left at the distant end of your EME path. In other words, the signal is going to be weighed down in the noise. This leads to the need for low-noise receiver amplifiers. If you can get just 20 dB of gain from a receiver amplifier, all of a sudden you'll have better than 1 V at the receiving end. The key here is low-noise amplifier. You want to amplify the signal as much as possible without introducing more noise. Trust me, the signal is going to have plenty of noise without the amps adding more. As mentioned above, at SHF and higher frequencies, the parabolic dish starts looking pretty good. At 1.2 gigahertz, a 2 meter, about 6 feet 6 inches, dish will give you around 25 dBd of gain, so the path loss is significantly better. If you slave, a fancy word for stacking, 2 or more dishes together, you can reach 30 dBd or more of gain. Of course, your backyard will look a bit like the VLA radio telescope site in New Mexico. One word of warning. There is no way on Earth or the Moon you're going to convince your significant other or the local HOA that those 4 big dishes in the yard are bird baths that keep falling over and pointing at the moon. And speaking of pointing at the moon, no matter what type of antenna you use, you will need a way to accurately point the array at the moon and to track the moon as it moves across the sky. This implies the need for a rotator that works in 2 dimensions, azimuth and elevation, at the same time. For Yagi arrays, rotators like the Yaesu G5500 DC, coupled with the Yaesu GS232B computer interface and suitable software, will do the trick. For parabolic dish arrays, each antenna needs its own positioning system, and all the antennas must be in perfect sync for everything to work right. Now, let's look a little closer at the feed line. If we assume that you need 100 feet of feed line to get from your shack to the array, we can assess different feed lines for their loss. We'll assume you're working the EME on 70 centimeters with a VSWR of 1.5 or better. The loss for several feed line types is shown below.
Technician band plan.
Feed line loss chart. The bottom line is that you're going to need hardline coax. But there's another option that is gaining popularity among the EME crowd: remote operation. The general idea of remote operation for EME is that the transceiver, amplifiers, and everything else is placed as close to the antenna array as possible. Then cables are run between the array and the shack. These cables will provide power, probably 240 VAC if you're running a legal limit amp, audio and control connections, and the 100 run will be easily handled. A common system puts a computer that runs everything out the array as well. Then you connect over your LAN to that computer and run things from the shack. Using remote operation, the feed lines to the several antennas can be kept much shorter, and that means less loss. And that's desired outcome. Lastly, we need to talk about the modes used on EME. The various digital modes, FT8 fourths, JT65, Q65, and CW are few. Far and away are the most popular and the most effective for EME work because they can be copied at or even below the noise floor. By the way, yes, CW is indeed a digital mode. Think about it. Digital, as commonly understood, is a series of binary ones and zeros, on and off pulses if you prefer. CW is just exactly that. So the right answer to the question of when the first digital communications mode was developed is 1837. Most EME stations today use computer control and mode operation with WSJDX, and JDDX being the most used software. Full Digi is also used quite a bit, especially for CW, while there is no reason at all requiring you to use machine-generated CW. There is a distinct advantage. Unless your CW fist is very near perfect, by the time your choppy CW signal gets to the receiver, it may very well be unreadable. Machine-generated code will be perfect when it leaves your station, so it will be in better shape when it finally gets to the receiver. Voice operations on the EME circuit are indeed possible. Many of the biggest EME stations can and do use SSB and AM for communications, but doing this takes the station construction and operation to a whole new level of difficulty and expense. Note that for a variety of reasons, FM is almost certain to fail. Digital voice modes like DMR, C4FM, Star, P25, and others are more or less an unknown facet. To my knowledge, in a review of the literature, shows no data from actual tests, but the hurdles would be close to that for FM. It would be interesting to see if digital voice could be made to work. As a general rule, you can successfully work EME on the digital modes by calling CQ. On voice, the vast majority of stations set up a schedule with other stations. One of the neat things about EME work is because of the light speed delay for the round-trip signal. Because of the distance of the round-trip path, you can send a signal. Let's say your Callsign in CW on key and hear your signal coming back from the moon. The delay is between 2.5 and 3.0 seconds, depending on the exact distance between the Earth and the moon. Conclusion: EME is not easy, nor is it for the faint of heart or those just wanting to play around with something new. It requires a well-planned and dedicated decision to make it all happen. The expense is also a big factor. A legal limit amplifier for 70 centimeters will set you back many thousands of dollars all by itself. With all of that said, EME can be very educational and rewarding. You will find that the hams working EME are an esoteric bunch. Ever been to Comic-Con? Well, the same sort of people who are deeply involved in the world of science fiction are also EME gurus. Their passion is also very contagious. If there's enough interest, at a later date, I may do an article for actually building a cross-Yagi array for EME work. We'll have to see on that. Next time on the Antenna Farm, we're going to look at something that I've had a few questions via email and on the ECR about: impedance matching transformers. If you know of an antenna construction article on the web, please drop me a note with the pertinent information, and I will look at it for consideration as an article for the Antenna Farm. Take care in 73. Charles, KC6UFM. Previous articles by Charles, KC6UFM.
Text or email to get your spot in the log. Our nets can be so busy that people have a difficult time getting in. We want to help everyone get on the air, so we came up with a unique way to get more people on the air. Text your call sign to 716-317-9050. Standard messaging rates apply. You can also email your call sign to text@ecr.radio. This will get you onto the log. This is not for ins and outs. It's to help get people on the air and through the pileups.
QSL cards courtesy of hamgallery.com.
The ECR has unique log sheets, and you're welcome to watch along. You can see where you are on the log, answers to the questions, and even birthdays and more. Go to bit.ly/ECR logs to get access to view all of the net logs.
You should know. The East Coast Reflector and its Reflector Magazine is all volunteer run. We charge nothing to use the system and nothing to subscribe to the magazine. The system has hundreds of nodes and repeaters connected at any given time. We incur a lot of expenses to maintain such a large system. If you use the system or enjoy the magazine, please consider helping by contributing to the system by going to eastcoastreflector.com and click on Donate. Your contribution is greatly appreciated. Continued from page 48. Grid Dip Oscillator, SM0VPO. Bridge, where the meter is deflected by the current caused by the voltage difference between the two voltage dividers. Naturally, you could add a modulation input as yet another additional feature, and I think I may well do this as some of the finishing touches to this project. This oscillator will give both AM and FM if you capacitively feed a signal into the source of the transistor. The meter balance pot also gives a very fine frequency adjustment if you are using a narrowband receiver to detect the oscillator. I have a few more toggle switches so I could add an internal microphone and an external modulation input. It would make a good wireless microphone for 88 MHz to 108 MHz FM band. You could even add my 222 stereo encoder and make a meal of it, but reduce the 10 nanofarad source bypass capacitor to 1 nanofarad. The possibilities are limited only by your imagination. Here are a few suggestions to get you started, but the ninth suggestion is probably the most useful idea. Internal 1 kHz test tone oscillator. Internal monaural or monophonic microphone. Microphone plus internal 88.1 Hz repeater access tone. External mono input, example, from guitar. 222 stereo encoder with stereo input. Sawtooth oscillator, scope time base O/P, to make a narrowband sweep generator, wobulator. 6-channel RC encoder. 8. Crystal oscillator plus mixer plus AF out to make an AF generator, or a metal detector. 9. Add something else clever here and tell us on my message board. The coil is tapped at 50%, which is often considered a disadvantage by many constructors, but for me, this is not a problem. It allows me to reuse the same coils in other projects, such as a simple signal generator and a regenerative receiver. I want to do some experiments with tunnel diodes and lambda diodes, so a ready stock of standard RF coils is a benefit for me. Construction. The meter was robbed from an old hi-fi cassette recorder that I stole from the Marsta City dump. The meter fills the whole width of the 105 by 62 by 26 plastic project case. Yes, the new project uses a case that is smaller than the previous GDO project, and it will even fit in my shirt pocket if I remove the coil. I bought the variable capacitor from China for about $2, but I had to buy a pack of 10 of them. You can still buy those cheap and nasty AM transistor radios from China, and I even found a few radios in Chinese. Bazaar shops in Spain. If you have the possibility to let me have a few new P-channel FETs, similar in performance to BF256A, then I will send you a 4-gang capacitor VHF/UHF tuning capacitor. Please check with me by email before sending. Unfortunately, they came without the 2.5mm machine screws. Due to hand capacitance and such, you really need to have a metal ground plane for the oscillator and the frequency-sensitive components. I took a piece of copper-clad board for making PCBs and cut it to fit into the available space in the plastic box after the big chunky meter was fitted. The ground plane was sprayed with photoresist, which prevents copper oxidation. The PCB is held in place after being drilled to take the machine screws to mount the variable capacitor. I used longer M2.5 bolts to hold the capacitor because it also sandwiches the box front plate. Note that the bolts must be so cut that they do not go into the capacitor more than about 1.5 millimeters, or they will foul on the brass tuning vanes inside the capacitor. Be a contributor. Do you want to help contribute to the magazine? Send in your article, project, story, comment, and suggestions to editor@ecr.gmail.com. You don't have to be a good writer if you have a good story. Everything will be published and sent to you before it's published. The coil socket is a simple 5-pin DIN, but I only used 3 pins. The coil socket hole in the case was drilled and filed to fit the socket, but I did not have the space to use the mounting bolts, so the chassis tag was soldered to the copper board, and the chassis was superglued to the case top. When the case is put together, it is surprisingly stable and robust. The DIN socket soldered and glued to the case top shell. The coils are wound using 0.25 mm diameter enameled copper wire. The coil formers are all 15 mm diameter and are the little plastic tubes for the thermal printer paper. They throw them away from the supermarket checkout till machine. So you can ask your local Walmart, Morrison's, Lidl, ICA, or Asda supermarket to save them for you. You just need to do as I did, chat up the girl behind the counter, but not when the wife is there. One coil 10 plus 10 turns for 8 MHz to 22 MHz. The first coil, above, covers 7.8 MHz to 22.1 MHz. The coil winding is 15 mm diameter 20 turns, 10 plus 10, of 0.25 mm diameter enameled wire, close wound, with 45 mm jumper leads to the socket. The ambient room temperature was 21 degrees Celsius, and the relative humidity was nearly 55%. I applied about 300 grams of winding force, and the coil was lightly smothered in superglue, wiped off with a dry cloth, and I unglued my finger and thumb using isopropyl alcohol. You may want to compare this with the earlier GDO1 project, where you will find the coil winding data for all the other coils. If using the 15 mm diameter formers I suggest for GDO2, then the new frequencies will be about half those in the GDO1 coil winding table due to the larger coil diameter, about 60% of the frequency.
The ECR has nets for everyone, including HF nets.
As you can see, there is a good frequency overlap. The upper half of the dial becomes progressively cramped as the frequency increases, so the overlap ensures that you always have a coil that will give you a good readable spread for the frequency of interest. I have only one more coil to wind, 1 MHz to 2.5 MHz-ish. I will update the above table as and when they are complete. All the coils built so far, 1.7 MHz to 180 MHz. Calibration. The scale is 50 mm diameter. One lesson I learned from the old GDO project is that after about 10 years of use, the dial became difficult to read due to smudging and dirty finger marks. So I recommend that you use a circular cursor that covers the whole dial. You can visit your local Lions shop, car boot sale, or Red Cross shop and buy an old cassette. Please choose any Rap or Barry Manilow cassette. The plastic case is perfect to cut out a cursor, and the Barry Manilow tape you should throw away. You can fit a temporary thin strip cursor for calibration so that you can write on the dial. I then recommend you scan the dial, use Photoshop, and create a new dial using the calibration marks from the scanned document. The result will look a lot more professional. Sweep the dial from end to end and measure the frequency. Note that there must be no metal objects close to the coil during calibration. Mark the dial with key frequencies. If you are a radio amateur, then you may want to prioritize the HF bands, then scan it when you have calibrated. Do not select rescale or the pixel resolution will get worse. Just like a Microsoft icon, choose print size and it will keep the same pixel resolution. The actual calibration to identify frequencies can be done in a variety of ways. One really crude way is to use an FM radio with no antenna, then find the harmonics. If you find a harmonic at 90 MHz and the next one at 108, then the GDO is oscillating at about 18 MHz. When the original GDO was built, it was a real pain in the ass to calibrate, but today there are SDR receivers, Raspberry Pi spectrum analyzers, and all manner of frequency counters, and even a little frequency counter using a PIC processor. I shall hopefully post my PIC frequency counter on www.sm0vpo.com shortly, complete with SW, PCBs, and photographs. The project is quite simple. The SW uses routines based on other designs, but it is just a 5-digit frequency counter. I did not program any frequency offsets, if shift, USB LSB shift, RIT, overhead underhang, or any of the bells and whistles budding young programmers seem to love spending hours to code. My frequency counter only counts frequencies, and from 10 kHz to 50 MHz. The finished GDO2 project. In the picture of the almost completed GDO below, you will notice that there is only one coil provisionally calibrated, and the dial cursor has not yet been fitted. This I will finish later, but lash up, temporary, coils show that the GDO works well from 200 kHz and up to 200 MHz. It works well with all the coils from my old GDO, although they have a smaller coil diameter. If I have the time, then I will update this project with the rest of the coils, but for the moment, you have a working project, loosely based on my previous project. It took a lot of effort to build this project since I do not now have any proper workshop facilities. I did not use a saw to cut anything, so that there was the minimum mess in the sitting room. The box was repeatedly scored with a Stanley knife to make the hole for the meter. I only had to use a drill for the round holes, but do not let Majlis know I was drilling in the sitting room. The project looks good, at least, it will when the finishing touches are complete. The project draws only 3.5 mA, so the batteries should last for years with normal use. I may look into the possibility of putting a white LED behind the dial and put that in series with the red LED. It will not take any more current, but it may make the GDO a bit more sensitive to battery voltage. We will see. Finally, I know that several of you have reacted to my old GDO project and the terminology I use. Grid dip oscillator is the original term used for this instrument when it was created using vacuum valves, tubes, and I don't intend to call it a drain dip oscillator. I mean, floppy disks were floppy in the 5.25-inch format. 3.5-inch floppies were quite stiff disks, but they never changed the name to Stiff Disk Drive, SDD, did they? When photography started using several sequential pictures, they called the pictures movies, and when sound was added, they updated them to talkies. Today we have reverted back to movies or films even though they are no longer developed on a kilometer-long strip of celluloid film.
Social media. The ECR is building up its social media presence. Join our Facebook group so you can enjoy our ham radio content and stay up to date on ECR information, and so you can update us on your ham shack and ask questions. Just like on the air, we don't tolerate trolls. You're free to ask questions troll-free. We keep it an enjoyable place. Check us out also on X, Twitter, Groups.io, YouTube, and most recently Discord. We look forward to you joining us.
Conclusion. With this project, I have achieved all my goals, and I feel more confident to give demonstrations to 60 people with this better-looking instrument. I am also a little surprised that I was able to get it into a box so small. Everything is shrunk to the limits of practicality, and still the huge meter looks good on the 6-meter projector screen. I hope that this GDO will last me another 35 years, or more to the point. Now that I am 65 years old, I hope that I will last another 35 years to use it, but 35 years from now, I may not be so good at climbing trees to prune my HF antennas, so I may be asking one of you to help me with that. This GDO is simple, easy to make, and I built this one in just one weekend in the sitting room, including gathering all the bits I needed. The total building cost is around. Prices converted from SEK to USD. I must also add that the GDO is perhaps the most useful instrument I have ever owned, and it has been the major instrument in my homebrew experiments for the past 50 years. My first GDO used a 6J5 triode, RCA, octo bass, in a metal envelope. I placed the GDO before the oscilloscope and spectrum analyzer, and in that order. I hope that you enjoy this project, and if you are an avid radio constructor, then you may find this project very useful for pruning antennas, cutting coaxial balance, multi-band antenna traps, making coils for receivers and transmitters, as a quick and dirty signal generator, even measuring the lengths of long wires or impressing 60 people at a time when delivering a course. Don't forget to visit my message board if you have any questions about this or any other project. I always look forward to receiving feedback, positive or negative. You do not have to register to post messages. Very best regards from Harry Lythal. SM0VPO, Marsta, Sweden. Original article at sm0vpo.com. Previous articles by Harry SM0VPO.
Operator oddities. I had a mismatch and set off the fire alarm at the clubhouse next door once. Didn't realize it until all the fire trucks pulled up outside. Oops. Stevie.
Net questions. Here's a list of most of our net questions. Ever wonder how your answer compares or what the results were? Click the question to see the results. There's questions from the Morning Brew, and the Tech Net and the Trivia Net.
Did you know that we have a gift shop? You can help to support the East Coast Reflector at the gift shop. You can get your Callsign put on an ECR shirt starting at $17.68, coffee mug from $12.60, or a polo from $22.49.
Silent keys. W4RH. Frank. Fort Walton Beach, Florida. KU4RB. Donald. Sebring, Florida. W3DA. T. Bridgeville, Delaware. VE3MRV. Merv. Lindsay, Canada. N8AA. John. Fairfield, Ohio. N8RPA. Brian. Macedonia, Ohio. Please keep these people in your prayers and their families to give them the strength, encouragement, comfort, and peace of mind and heart they need.
Magazine Archiver. Thank you for listening to the Reflector Magazine. If you'd like to subscribe, go to bit.ly/ECR subscribe and enter your email. Disclaimer. The content, opinions, and views expressed in this magazine are those of the authors and contributors and do not necessarily reflect the opinions or views of the publisher, editorial team, or affiliated organizations, or anyone else. All articles, images, and information provided are for informational and entertainment purposes only and should not be considered as professional advice. The publisher, ECR, and its volunteers assume no responsibility for errors or omissions in the content provided. Readers are encouraged to verify all information independently. The use of trademarks, logos, and brand names does not imply endorsement. Reproduction or redistribution of any content in this magazine, in whole or in part, without prior written consent from the publisher, is strictly prohibited. For inquiries or permissions, please contact Vicky, ke8vky@ke8vky@gmail.com.